Hi everyone, Electro here. I hope everyone's having a good break. It's a nice day here today. I'm just about to go fishing, but I thought I'd make this video before I go because something funny happened yesterday. This is my other alternator. It's I don't know if you all remember this one, but this was the wind I was showing you guys. It's like a DC motor sort of thing. But anyway, I've put this on. It sort of works. I did a few things with it, but just for a comparison, I put the other one together and put that on. Now this one here I've went a little bit different. It's sort of like, I've tried to make sort of like a transformer generator sort of thing out of it, but here's the thing. The other day when I was running it, just on this motor here, now with this motor I was only using 30 volts on this half of the power supply because I wasn't too concerned with speed. I just wanted to see the action of the coils and the coil combined. So what I did was ran the alternator off this side here with these two leads here. Now, as I was playing around with these and I was crossing some with others, etc., trying to complete the circuit that I was trying to make, I got like a static spark off couple of the wires and I approached them with another wire. I don't know which one it was or anything because it all happened in, like, you know, in the course of things, not really paying attention to that sort of thing. But to cut a long story short, what that did, well, I don't know what it did, but as soon as that happened, this thing started freaking out, and the circuit that the alternator leads were connected to started tripping itself on and off and just went haywire. It started pumping out the volts, and as you can see, it melted my my leads going to the alternator. Now this was only set at 5 volts. This one here was at 30 volts driving the motor, or 28, something like that, but that one there still works okay, and so does the separate 5 volt supply. But this supply here now, even though the relay is clicking on and off, just pumps out the volts. It doesn't stop. So listen to it when I turn it on, and that's everything's turned down, and that's still 42 volts. It won't go down like this side will. Anyway, I better turn it off because it's already making a funny smell. Funny thing, because the only thing that was connected to was the brushes of the alternator, which is an electromagnet, not connected to these things, and these are self-power. But see, I've spoken of this curse before. Something with an electronic circuit in it just fries itself. Enough said. Anyway, moving on. A couple of different experiments I was trying. Just this is my new experimental cell. Anyway. This is a plastic washer separating the top from the bottom, and as you can see, these are solid stainless. This is just an idea I've got to try out before. These are for the gas gun. Well, the bar was, so I thought I'd try this before I cut it even smaller, or whatever, and make for the gas gun. But yeah, that's one of the experiments I'm doing. The more significant thing, and what the title of the video probably will be, is the new Tri-electrode. Now with this, I read Stan's Canadian patent on his spark plug a couple more times, and he speaks in that about self-ignition and how it's hard to achieve, and sometimes it would be beneficial to employ an external ignition source. So I thought about it, and I'm going to try to incorporate it in the same electrode, the central electrode of the conventional plug. And like I said in the beginning when I was designing the plug, I've designed it this way so I can change a number of things with a minimum of remachining. Now, even though I'll have to get that machined again, the inside of this, everything else still stays the same, so I can still use This I just have to modify, which means making that hole bigger, tapering off in the end, so I maintain the same hole there. All I'll need is a different electrode and to drill out the ceramic piece there. Now I've started to do that, and the front of it, I'll just focus that for you. I don't know if you can see that, but it chipped, so I've ground it flat, but I don't really need that area anyway. So now I'm approaching it from the rear end. I'll focus that again, and I want to use a lot more water this time, because otherwise it just cracks. It's especially when it gets down there. But anyway, that's how that's going. I'll finish that soon, and this is more about the design of the electrode, how it's going to be. Now, we've all seen Ross's video on his electrode, and it's the proper shape. It's kind of domed, and it's closer to the drawings than what I had. This is just really because it was nice and easy. But having a look at that and thinking about this, I figured it's time I can make it now. So say I start with just a normal stainless steel electrode that's been correctly shaped at the tip, so it's the dome shape that we need. I'll then drill a hole through it. The hole is about 2.83 millimeters wide, or round in diameter, and that goes all the way through to the end. Now, in the end there, I'm going to place a tube, a ceramic tube, and the ceramic tube itself has 2 holes in it. I've got a better drawing here of that. That's a closer representation of the tube now. Say that's the tube, it's got a cap which I'm going to machine up for the top of it, and internally it has 2 holes, one exiting on this side and one exiting on that side, sort of like that. The blue part there represents the ceramic. This is the metal electrode, and these are the separate spark ignition electrodes that are part of this design. Now, to explain it further, after you draw the electrode, you insert your ceramic piece, and in that piece you've got stainless steel wires coming up there, which I can fabricate 2 custom electrodes for the tip there. Now, that's those there. They're held apart by the ceramic material, which is blue, and the tip of them is open to leave an area for it to spark in. My thinking on this is, if that's the electrode, which is inside that, like the normal electrode would be in there through that hole. Like I said, we'll have a bigger electrode that's hollow, and inside the electrode will be another 2 small electrodes, all surrounded by ceramic or fused to it, and all that sort of thing. That's a different challenge in itself, but I know how to do that, so I'll show you all when it's finished anyway. So there. I know it's a bit complicated at the moment. That's it from the top view, so you'll have this section here will be split, so the spark will occur between that area there. Now, as that comes down, you'll still have the 0.25 mil gap on the outskirts to the external body, and if I can make enough hydrogen in here, as it exits there, that's where the spark area will be, and hopefully, yeah, signified by that. That's the plus, that's the minus. That'll go to something like a ignition coil to create that spark, and see how it goes. Anyway, I'll keep you posted on that, as well as my progress with this. What I'm trying to do with this, there's a guy called Brian Coates. He's done an experiment where he's got he's got an alloy tube actually on the inside, I think, and the shortest stainless tube on the outside. And not only does he get his to act like a capacitor, he also gets it to operate while it's not connected, but it operates in a funny motion where the gas goes up and circulates around. Check his videos out. I saw that and it was intriguing, so I thought I'd try to replicate it and just see the results, and it's part of the reason why I was trying to make that as a power supply to power that, and that's what happened with that. So because of that though, I'm afraid all this will be on hold for the moment, because one of those is pretty expensive, and yeah, that one's fried. So I know it still works, but I don't want to use it. It makes a funny smell. Like, yeah. So another one for the scrap heap. Anyway, I'm just about to go fishing, so I'll talk to you guys later. Bye.